You're not going to want to miss this episode of the AI Show where we talk some high-level MLOps from Microsoft data scientists, ML engineers, and data engineers. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking to some Microsoft data scientist, a data engineer, and an ML engineer. It sounds like the beginning of a really fun joke. They all walked into a bar. What happened? We're going to talk about high-level ML ops. So why don't we start with some introductions? Spyros, why don't you start, buddy?
Great. So I'm Spyros. I'm a data scientist with Microsoft, and we are here joined by my esteemed colleagues Davide and Sam as part of an AI task force, a data scientist, an ML engineer, and a data engineer. And we're part of a wider team that covers EMEA and worldwide time zones. And what we do is that we enable our customers to formalize, design, and implement data science solutions in Azure. I'm the data scientist of this team. Pass it back to you.
Let's go to Sam.
Hi, my name is Samarendra Panda. I'm the data engineer of this team, and I work as a data and AI consultant for Microsoft Industry Solution team.
Fantastic. David.
Hi, my name is Davide Fornelli. I'm based in Italy. I'm part of Spyros of the Customer Transformation and Innovation team in Microsoft. In this AI task force, I cover the role of the machine learning engineer.
Fantastic. So I know you can't talk about customers in general specifically, but what kinds of projects do you work on? I'm sure it's a bunch of them. Who would like to speak to that?
I'm going to speak about that. So the latest project that we have delivered, and as part of this particular task force, was with the largest UK energy supplier, and that was a supply and demand optimization problem combined with field service appointment optimization. So it was a lot of overlapping ML models working with each other and on top of each other. Another one before that was with the world leader in shipping, and that was about fuel consumption optimization and route optimization using onboard IoT sensor data. And the list goes on. There's multiple projects across all disciplines, from finance to healthcare to anything you can think of.
So when we're talking about these particular projects, are they all like completely different from one another? I'm sure there's aspects of that, but are there common things as well that you see in them?
Yeah, absolutely. They can be very different in terms of the context or the domain, but when it comes to AI and ML, there are a lot of common patterns, and especially with our experience delivering such projects. And this is the topic of today's show, I guess. One of them that stands out the most is how important it is to do proper machine learning operationalization, aka MLOps. How critical it is, and what effect it has downstream for a project.
Yeah, and I briefly showed the screen, right? The whole concept of MLOps, but for delivering value, which is pretty cool. So let me ask this question, and let me point it to you, maybe, Sam. There's got to be some common pitfalls that people jump into when they're doing these projects. What are you finding that's just the common challenges? We'll go to you, Sam.
Yeah, so that's a very good question, and I would like to talk from the data perspective, and then I'll hand over to Davide to talk from the machine learning perspective. So let me just talk about the data from the data perspective. So in my experience, I've seen that most of the time in any of the machine learning projects, the main concentration goes into the model training or optimizing the model to get the better performance metrics or scoring of the model. Although I believe that these are important, however, not having an automated data ingestion pipeline as a step or part of the process makes a better model perform really bad over time. If we are not training the model with the recent data, the model will be biased towards the previous version of the data, which is really bad.
Right.
And then one more problem what I have seen is basically the integration point between the data scientist and the data engineer. I'll just give you an example. So let's say that the training script, the model training script doesn't need lot many features. It just need couple of features. But the data engineer who is working on the project or the data ingestion framework is basically sending lot of attributes or lot of columns to the training script. Or let's say that the machine learning model is supposed to train the model on a specific hierarchy. Take an example of geography hierarchy, and the training of the model is basic. The training of the model should be done based on the country, but we are supplying the data or we are providing the data based on the city level.
Mhm.
Hence, what's happening that we are providing lot many columns, lot many rows, and that basically makes the training of the model becomes really slower because we need to do some kind of overhead functionality like aggregating the data or feature engineering and all those kind of steps we need to perform just before we actually get into the actual training algorithm part. So I believe these are the main pitfalls or the problems what I have seen in any kind of machine learning project.
Yeah, and just to summarize, I love the like. Look, I'm a I went to school and did research, on like building machine learning models. So that part is super interesting to me. But your model's only as good as your data process. I think that's what you're saying, right, Sam?
Yes, yes, that's true. If the processing of the data is not great, or if it is not automated, or if it is not meeting the SLA, then no point of having a good model because that will perform bad over time.
Cool. All right, David, what are some of the common challenges that you're seeing?
So I would like to take it a little bit far the answer. So there is a reason why in the sentence data science, there is the word science in it. It is an exploratory activity that, given a thesis, it requires experimentation to prove its feasibility. So this means that more are the experimentation cycles that you can complete, higher are the chances to find a solution for the hypothesis. The experimentation cycles are also useful to gather a better understanding of the actual business need, because sometimes we start with the customers with an overview of the business need, which is going to become more specific across these kind of cycles. So it could also happen that the business need that we used at the very beginning, at the origin of the project, is going to change over time. So the experimentation velocity of these cycles and the solution flexibility that we are delivering, which has to be capable of shifting depending on the business needs, are two of the main pitfalls and key features that we have to manage in our project.
And that's really cool because, I mean, the word science, everyone thinks it's like, oh, it's so scientific. But science is really a rigorous process of guessing and checking. I mean, am I saying that right?
Exactly. That's perfect. That's perfect. And more experiments we do, higher chances we have to solve the business problem. So to be really quick, so the concept of velocity here comes from the agile methodology. So we apply the concept of velocity of the development team to the velocity of the data science team. Okay, so higher is the velocity, more experimentation gonna be able to do, higher the chances to reach to the solution of the business problem.
That's really cool. Spyros, what are some of the challenges that you've seen, my friend?
Yeah, so following up from what Davide said about science, we have to remember, right, that you can get a PhD by trying to prove something and getting to the point where you can prove that it cannot be done, right? So that's one thing that the customers never have in mind. That's one thing that sometimes it's not possible. And then building up on that, it's the thing that what I find the hardest from a data scientist perspective, in close contact with our stakeholders and the business customers, is that first of all, the MLOps part is very often either varies from being underestimated or being missed completely in the planning stage, which is a big problem. Then the most of the difficulties we run into have to do with the definition of the data science user stories and targets, and the definition of done and the success criteria. For example, what should be the evaluation metrics that we should choose? When is a model good enough? Is 90% good? Is it bad? Should we try for 91%? And when do we accept that there is a realistic value for those metrics to be successful? And when are we done with the experimentation? So those conversations are very, very important. And another thing is that very often it is difficult to decide when we should actually go for data-driven modeling approach versus subject matter expert inputs for decisioning. When should we go with the data, and when should we go with the experience and the gut feeling? And both of those things built on top of everything else that the guy said.
I personally think, like, I know we should think about these things, but like, what does it mean to have success? What does it mean to be done? And then maybe we don't need this at all. I mean, I've had customers come to me and ask me, "Hey, I want to do this thing," and I'm like, "Hey, that sounds like a database lookup, and not actual AI." Have any of you had something like that as well?
Yeah, it's actually funny that this is so. Working for Microsoft has this good thing that we're not going out there we don't have to sell something by force, right. And that gives you the flexibility to operate with honesty and transparency. And I find it, and we've all seen that with our customers, that they really sometimes they're flabbergasted when we say, that sounds cool, but we're not going to waste your time. It's not going to work. It's not going to bring you value. There's no point in doing that. Here's how you can do it another way, cheaper, faster, and without going into the whole big data hype. And that, having the ability to do that builds trust, and it's the best way to go because it's like the honest way to go. So, and if we are realistic, there are some cases where you don't need to go, with deep learning, for example.
Yeah. I mean, I always start with decision trees and logistic regressions, and always start simple and then get complicated when you have to. Here's another question. I'll put it to you, David, and then we'll cycle through. We've talked about the table stakes challenges. Have there been surprising challenges as you've worked with customers that you're like, oh, this is interesting. I need to make a mental note of this for next time. What do you think, David?
Yeah, so as a machine learning engineer, I like to think about the life cycles of the models. So one of the considerations that I make, and I do this also with our customer, is that the model's environment is different between the POC, where you study the model, and the real world, where you're going to use the model. So during our design sessions with the customers, I typically suggest to experiment with the real world in mind. Something like keep in consideration how the data is ingested, as Sam was mentioning. How is the scoring done? Which are the timings constraints for the training and scoring? Which is the source data during the training and the scoring stages? And the list goes on. So designing a machine learning solution, so what we do as consultants, is not only about designing the architecture, but it is mainly about designing the overall life cycle of the model.
Interesting. Spyros, some other surprising things?
Well, that's a kind of an easy one, because it is surprising, even for me, how often the customer will underestimate or overestimate the quality of the data that they own. So we see it's pretty often the case that people are influenced by the tech sphere hype, and they go after high complexity use cases that are very challenging to even define. And very soon, I mean, if you know what you're doing, you can very quickly spot that either there is no data available at all for that use case, or that the granularity or quality or frequency of the data is not appropriate for that kind of problem. So what is surprising, and it shouldn't be surprising, is that big data by itself cannot solve any problem, and AI, with big data, it has to have some quality aspects that come with it. Another point is, which I find surprising, is that it's still the case that many times we see that a business will find it, will think that it is almost equivalent to replace data-driven structured data flows with people-centric flows, and to have the belief that the people-centric flow will either be less error-prone or at least as good or as fast as a fully automated pipeline. And this is what we do, basically. This is where we come in and we explain and demonstrate with POCs that that's not the case.
Interesting. Sam, let's go to you. Surprising challenges that you found.
I'll just talk about the real the development scenarios. So for example, I have seen that if you go to any customer place, and they would be having so many models, and now they probably be choosing any tools for the machine learning, like any compute there will be, which would be there to train the model or inference the model. But one common thing what I found, that let's say there will be some common script, like creating the compute or creating the data store, creating the mount point, everything will be scattered, and all the machine learning model would be having their own version of the script. Now, like, there is no modularization, there is no module concept, or nothing is there. So I really found it's really difficult to work in those kind of scenario. Let's say one data scientist working in some part of a machine learning model. Now, let's say he is going to shift to a different machine learning model problem. Then he needs to go through the whole framework again, because that has been coded differently. So I believe if we do not have any kind of standardization or the uniqueness in the framework, that will create a lot of problem. Because in the machine learning process, what I feel, only the changes what happen is the input, output, and the environment and the training algorithm. Everything else remains same, and that everything else can be standardized across the organization, across the different machine learning problems.
And that's really cool, because I think it's hitting on something that this is what I want to get into now. You talk about standardization. My sense is that some patterns emerge the more customers you work with. Can you talk about those patterns a little bit? We'll start with you, Spyros.
Yeah. So basically, what we've realized is that the main pattern is that it's not enough to have data science and AI involved in a project. You have to basically have a solid and flexible framework for machine learning operationalization, MLOps, as we call it, which covers three basic principles. One is that obviously it follows the DevOps methodology for machine learning. Then it uses the machine learning technology and enables the models to go end-to-end to production. And it also allows for an agile culture. So it needs, this needs to be in place so that we are flexible and we don't go down the road of chasing down a standalone use case and go waterfall trying to solve it, and then only to realize in the end that we need to change course or rebuild or throw away everything we've done for the last 4 sprints, for example. So only if you have a solid and flexible framework for MLOps, you maximize your chances of being prepared for any eventuality, and maximize chances for success.
So let's talk about, because we kind of been dancing around this notion of MLOps. How would you describe MLOps? Who wants to take this one?
Spyros, you can go ahead with the discussion.
We have the deck. I think we can bring up the deck. Yeah,
bring it up here.
So this is what it looks like MLOps in delivery, what it looks like in real life. So MLOps is a set of practices and rules that allow the, it follows the DevOps guidelines for machine learning. And in terms of the technical aspect, there is not a lot of differences. What we're showing here is what it looks like from the people perspective. That the mission, what we do as an AI group here, the three of us, is that we go in and we have overlapping skills to some extent, but we are each one are experts in our area. So the data scientist will be covering the modeling aspect and creating the model to solve the problem. The ML engineer will also heavily participate in that, and also in tuning and operationalization. And the data engineer will be predominantly doing all the implementation of the pipelines, the environments, and the framework. And what's important, what's the key takeaway from here, is that it is about not just the methodology, but also the technology used and the culture. So you can't have one without the other. You can't run this successfully without having a very competent data engineer, for example. There is, unfortunately, I'm going to spoil this for you, Seth, that we can't have a unicorn data engineer or a unicorn data scientist if we're talking about a serious level of commitment of a project. If it's a standalone POC or a hackathon, you can do those things. But for a full-scale operational project for a large customer or a large organization, you really need to have the interoperability between these three roles. And that's why we are successful when we go in like this.
That's interesting. David, do you have something to add here?
Yeah, so like in the next slide, we're going to discuss also about which are the principles, about the MLOps in delivery. So basically, the principles are four. When we deliver something, we are based on 4 pillars. The first one is the change management. So also this is something that most of the time is underestimated, because when AI is involved, it's going to change some business processes. The solution that we are going to make is going to be used by someone from the customer side. So we need to take care that the customer and the team of the customer, so the end user, is going to be able to use what we're going to deliver as it best. Okay, and without any sort of fear, because sometimes AI is perceived as something that is going to replace the human being in their own job. Instead, AI, what the solution that we do, also for a concept of responsible AI, is something that is going to help the end user. It's not something that is going to replace the end user. So it's something that is going to be used with the human being, not in place of. The other pillars are more about the delivery, the technical aspect. One is the development environment, which is something, well, there are many types of data scientists, like as software engineers, you could have different flavors. I would like to use Python, I would like to use R, I would like to use Scala, and the list goes on. What we take care about is also to try to, let's say, establish the language. Let's say Python, okay? We are going to put all the software engineers, all the data scientists in a condition to be able to work in the same environment as quick as possible. So typically we use a Visual Studio Code with a Docker environment, which is going to be attached all together. And we're going to also create an environment that is going to work remotely with the cluster, with the compute target. These are technicalities that sometimes are kind of underestimated, because working with a remote Spark cluster from the local environment, it requires a lot of configurations. So if you have another team member that is going to join the team, you have to put him or her up and running as soon as possible. Another thing, another pillar about the more technical aspect of the model is that we have to be able to basically log everything. I love logging. Logging saved our life, professional life, many times, because when the model breaks, it's not going to send you an email, hey, I'm going to break. wake up. It's going just to break, and that's it. So you need to be, since sometimes what we develop, sometimes most of the time what we develop is mission critical, because we have the skills to commit to such missions. We need to be able to, if something breaks, to fix it as soon as possible. And logging the models is not that easy as it could sound. So we put it in place, a framework, a methodology, also to ensure that everything that is developed by our teams is going to be logged properly and is going to be easily searched when it is needed. The last pillar is also the architecture. So we need to be able to deploy the architecture in different environments in the same way every time. The customer can have dev, prod, test, pre-prod. Another environment is a simulation of like a digital twin of the production environment and so on. So we need to be able to deploy the established architecture in every environment with ease, like with just one click. Okay, so this is mandatory also. All these things help us to improve what we were saying before, so the velocity of the experimentation, and to increase the solution flexibility. Okay. So these 4 pillars are helping us to achieve to solve these 2 pitfalls actually that we were discussing before.
That's cool. Sam, what are your thoughts on MLOps, my friend?
Yeah, I think almost Davide has covered all those aspects, but I think I'll just try to add the data aspect of it, because as I have been saying, without data a model can't be a better model. So the only things which I can think of, having a good integration point between your data pre-processing and the machine learning model training script initiation. So for example, I'll just take one example. Let's say you have a Azure machine learning service. Now you probably be doing the data pre-processing somewhere else. Then you should be having a pipeline which basically tell us that when the pre-processing of the data finishes, then only you start the training. Like, you should not run in a silo mode. That should be having a good integration in between. So that's something I can talk about, like make it a like data pre-processing or the data ingestion should be the integral part of the whole MLOps life cycle.
Yeah, and this has been super good. Let's just finish off with this, because all of this information has been good. I love the pragmatic approach to this. It's not like, hey, this is magic. No, it feels like it's actually engineering, the stuff that we've been used to as programmers since forever. Any tips from any of you on someone that's like, yeah, we have a nascent machine learning practice that we want to start in our organization. What are some tips that you might have? We'll go to you, Spyros.
Right. Yeah. So I'm gonna touch on some things that we mentioned before. So I would say number one would be invest the time in the beginning to be very mindful, actually, to not overinflate expectations, and invest the time to explain that this is a scientific experiment, essentially. And anytime that you invest in the beginning to set up your experiment, to set up your target, what you're going after, as clearly as possible, it's going to pay off in the long run. Another thing I would say is avoid going for the solo superstar approach, but get yourself a proper task force of experts like we are talking about here, so that you can cover, even if there is overlap, but you can cover all of the things that you need to cover. And another thing that I would mention would be, again, pay very much attention to clearly articulate to the stakeholders what the possible outcomes can be of the experiment with ML. That it can be total success, total failure, and anything in between. So we have to be prepared for that, because one of the most common pitfalls that we didn't really mention was that many times in a project, the component of AI is considered as done before we even start, that we are certain that the outcome will be what we expect it to be, and we only come back to pay attention and realize that it is central, mission critical to the whole project when things go wrong. So way better to do not overinflate expectations, explain the possible outcomes early on, and pay attention and staff properly when you go in such endeavors.
Great tips. Any from you, David? Tips?
So like Spyros gave already some great advices. What I would like to add is just a repetition of what we said before about the architecture. So when you're putting in place a team, try to make, as Spyros said before, like there is no unicorn, but you could have a unicorn team. Okay. Once you have the kind of team, when you design your solution, keep in mind the model lifecycle. So basically, do not rush into coding the solution without having first in place clarified what you have, the full life cycle of the model, and experiment with the end goal in mind. Okay, this is going to, let's say, save your model life by far.
All right, to you, Sam. Tips.
Yeah, I think the tips is basically I'll just take the word called velocity, what Davide was mentioning, because as I work as a data engineer, most of the time what would happen when I'm starting a project, my data scientist would be waiting for me to process the data and give the data to them. So in those kind of scenario, I would rather be suggesting or can give the tips like, let's have a logical segregation between the different the roles and responsibility. Let's say data scientist wants to train the model, give him a quick snapshot of the data to him, so that he can start working on that, like he or she can start working on that. And by the time he or she finishes the model, you basically take care of the whole data ingestion piece, so that you can work parallelly. But that's something I can think of. And also, let's have a logical or the mutual agreement at the starting of the project, when you are designing with the data scientist. Okay, what you need as an input, what environment do you need, and where you will be providing the output. I think being an ML engineer or the data engineer, these three questions has to be answered by the data scientist. Input means like the normal model the data which is required to train the model.
Right.
Environment means the dependencies, the Python dependencies and all. And then the output, where if you have basically trained the model, where you are going to save that trained model, so that you can basically integrate the DevOps pipeline and the other activities, whatever is there. But I think these three questions has to be answered by the data scientist to the ML engineer or the data engineer. This kind of logical and the mutual agreement has to be there at the starting of the project.
Well, this has been super informative. Where can people find you if they want to get a hold of you?
Well, we're all on LinkedIn.
I have your LinkedIn links here. So this is Spyros here. If you want to get a hold of him, if you want to get a hold of David, here's his LinkedIn address. And then if you want to get a hold of Sam, here you go. That's for Sam. Well, this has been awesome, my friends. Thank you so much for spending some time with us. And thank you so much for watching. We were learning all about high-level MLOps from Microsoft, a data scientist, a data engineer, and an ML engineer. Thank you so much for watching, and hopefully we'll see you next time. Take care.
Thank you.